Okay, so this is a breakdown video. If you're still really struggling with Unit 2 as a whole with finding the parts on the isotope chart or being able to use them in a Bohr model and Lewis dot. Okay, I'm not going to explain Bohr models and Lewis dots in here. If you're struggling with that, go look at the formative number 2 video that I break it down. Okay, but this is just a general overview of the main parts if you're still struggling. Okay, so first we are looking at number of protons. Okay, hopefully for the most part, all of us are really comfortable finding the number of protons, but if you're not, it's okay. So this is based off the atomic number, all right? So if you look at this, if you look on your periodic table, okay, you have your atomic number on the top, okay? It should be a number without a decimal point, okay? So an example of the atomic number for magnesium is 12, okay? Meaning that the number of protons you have is 12, okay? It's the same as the atomic number, and it never changes for an element, okay? If you change the number of protons, you're changing that element, okay? Because it's based off the atomic number, all right? So that one should be the easiest one to find. It's always the same for every single element, okay? Each one has a unique one for the element, okay? It's not going to change unless you change the element. Okay, next, number of neutrons, okay? So we have some struggles with this one, all right? And I think it's because we don't always remember the equation, all right? So you have to remember that number of neutrons is based off the mass number, okay? So that's what's going to change. The number of neutrons, it's going to be the number of neutrons equals the mass number minus the number of protons, okay? So the mass number and the number of protons, okay, you're going to have to subtract the number of protons from the mass number to find your number of neutrons, okay? So if we look at our magnesium example again, okay, it's not an isotope, we're just pulling the information off the periodic table. So my mass number here is 24.31, and you're going to have to use the given mass number in the periodic table if you're not given the number of neutrons or if you're not given the mass number. Okay, so if we're looking here, if our mass number is 24.31, okay, you're going to take that minus 12 to get your number of neutrons, which should be 12, okay? Isotopes, okay, give you a different mass number. So the mass number will be given and you're not going to pull it off the periodic table, okay? So there's two ways in which the isotopes are shown. It's the name and then the mass number. So example would be carbon 13, okay? In that case, you're going to use 13 as your mass number, okay? So in that case, it would be 13 minus the atomic number for carbon, which is 6, okay? And that would get you your number of neutrons, all right? Another way to know if you have an isotope, okay, is isotope notation. So in this case, we have carbon 14. The mass number is going to be up above, okay? So again, that's how you find your number of neutrons, right? Either you're taking the information off the periodic table if mass number is not given, or you are looking at the isotope given and using that mass number to calculate your number of neutrons, okay? Next, but certainly not least, you're looking at for a number of electrons, okay? Your number of electrons is based off of the charge, okay? So number of electrons equals the number of protons minus your charge, all right? So if you're taking the information off the periodic table, all right, that means that is an atom. It has no charge, which is 0 charge. If you have a charge of 0, it means your number of protons is equal to your number of electrons, okay? If you have a charge, okay, so if you're an ion, ions have charge, okay? So if you're an ion and you have the charge, you're going to use the same equation as above, okay? And you're going to calculate how many electrons you have based off the charge, okay? So again, this is your golden equation for this. Put it on a note card, memorize it. You should know how to find that, okay? Last but not least, well, not last, but close to last, all right? Valence electrons, all of you should have this written on your periodic table. If you don't have this written on your periodic table, you need to phone a friend, okay, and get it written down. So it's based off group number, okay? So what that means is electrons in the outermost shell are valence electrons, okay? And they're the ones that generally are either gained or lost. So they're very important in bonding. They're very important in forming ions, okay? So I labeled the top of my periodic table here, okay? Just a reminder that every element in that group is going to have that number of valence electrons, all right? There is an exception in group 18. You would think you'd get rid of the one, you would have 8 valence electrons for all of them. However, we talked about this. Helium is in the innermost, only has the first ring, meaning that it can only hold up to 2 in its first ring. So for helium to be stable, it only needs 2 valence electrons, okay? The rest of group 18 is going to be your 8 valence electrons. All right, and remember, those are our most stable noble gases. All right, last, with isotopes versus ions, okay? Identifying these, all right, so if we look at an isotope is the same element. It has the same number of protons. It does not generally have a charge, okay? It has a different number of neutrons because it has a different mass number, okay? It's going to have a unique mass number for each isotope. All right, and we're going to talk about isotope notation on the next slide, okay? Ions, same number, same element, so we got our same number of protons, okay? Same mass number, same number of neutrons, okay? None of that changes for an ion, okay? However, you are going to have a different number of electrons because you're going to have a charge, okay? All ions have charges, okay? So that's how you distinguish between an isotope and an ion. Right, if you see a charge, it's an ion. If you see a different number of neutrons or a specific mass number, that's going to be your isotope. All right, so nuclear symbol or isotope notation. So I wrote out an example here for silicon. All right, that top 29 number is your mass number, okay? So it's going to go on the high left. On the bottom left should be your atomic number, okay? Based off that, we can find our number of neutrons and protons, okay? Then up on the top, in the middle goes your element symbol, okay? And then on your top right is going to be your charge. So in this case, we have a +1 charge for silicon, okay? So that gives you a lot of information. That may be in the last box, or you may have to figure this out yourself, but it's all information that you're able to find. You just have to put it all together and remember the order in which it goes. All right, so very last but not least, just a reminder to come in for any extra help if you need it. Okay, you can replay, break down this video. Make sure you're making flashcards. Okay, watching this video is not enough to study for. Okay, you need to be making flashcards, review guides, things like that. All right.